Assalamu alaikum, dear students. Hope you are all fine. So our today's topic is chemical properties of non-metals. It is having total 5 properties: reaction with oxygen, water, dilute acids, salt solution, and chlorine. So we will start from the reaction of non-metals with oxygen. As you know that oxygen is also a non-metal, and when non-metal reacts with non-metal, they lead to the formation of covalent compounds. The compounds are covalent in nature, unlike the reaction of oxygen with metals. There ionic compounds are formed. Here the reaction takes place by the mutual sharing of electrons. That means the bond between the non-metals and oxygen is covalent. And when non-metals react with oxygen, they form acidic oxides or neutral oxides. What are acidic oxides? Acidic oxides are the oxides which, when dissolved in water, they form acids. You have studied it in your last lecture that it is different from that of the reaction of metal with oxygen. There only basic or amphoteric oxides are formed. Here acidic oxides are formed. That means when the non-metallic oxides dissolve in water, they form acids. And neutral oxides are also formed. Neutral oxides are the oxides that are neither acidic nor basic in nature. I will show you in this example. Carbon, when it reacts with oxygen that is present in the atmosphere, in air, or it burns in presence of oxygen and it forms carbon dioxide. At that time carbon is taken in the form of coal, in the form of charcoal. When it burns in presence of oxygen, it forms carbon dioxide, and carbon dioxide is acidic in nature. Why is it acidic in nature? Because when carbon dioxide is dissolved in water molecule, it forms H2CO3. It is carbonic acid. It is having acidic nature. Number second is sulfur. Sulfur burns in air. It burns in two ways. It forms two types of oxides. First is sulfur dioxide and number second is sulfur trioxide. Both the oxides are acidic in nature. Just like this, when one atom of sulfur reacts with one molecule of oxygen, it forms sulfur dioxide. But when the concentration of sulfur and oxygen is changed, it forms sulfur trioxide. We will balance this equation 2 times and 3 times. It means when 2 atoms of sulfur are reacted with 6 atoms of oxygen or 3 molecules of oxygen, it forms 2 molecules of sulfur trioxide. This is sulfur dioxide and this is sulfur trioxide. Both are acidic in nature because when both are dissolved in water molecule, they form acid. Sulfur dioxide forms H2SO3. It is sulfurous acid. And sulfur trioxide forms H2SO4, which is sulfuric acid. These were some examples of acidic oxide. It also forms neutral oxide, which are neither acidic nor basic in nature. When carbon burns in an insufficient supply of oxygen, it forms neutral oxide. Here, the concentration of carbon is different. Here we take carbon in presence of sufficient amount of oxygen or with an unknown volume of oxygen. But here carbon burns in insufficient supply of oxygen. That means the concentration of oxygen here is very low as compared to that of the carbon. So it means it leads to the formation of neutral oxide and the name is carbon monoxide. When carbon reacts with oxygen, it forms carbon monoxide. When 2 atoms of carbon react with one molecule of oxygen, and carbon monoxide is neutral. It is neutral oxide because it is having neither the characteristic of acids nor bases. Last example is hydrogen. When it combines with oxygen of air, it forms a neutral oxide, which is the common oxide, hydrogen oxide, and its common name is water molecule. When it reacts with oxygen, it forms H2O, and H2O is neutral in nature. This was the reaction of non-metals with oxygen. Number second is reaction with water. It is important because non-metals do not react with water or steam. Whether we take water in presence of liquid form or in gaseous form, it does not react with water molecule, because you have studied it in reaction of metal with water. What happens in the reaction? Hydrogen, its most important characteristic is hydrogen gas. Hydrogen gas is evolved. For example, it is a non-metal. It reacts with H2O. The non-metal must evolve hydrogen gas. It here should be the element that should be electron donor. It should, in order to evolve hydrogen gas, the element which is reacting with it, that must be electron donor in nature, or that must be only metal, because metals are electron donors. But here when we take a non-metal, any non-metal, non-metals are electron acceptors. They do not donate any electron at all. That is why the non-metals will not react with water molecule, because non-metals can't give electron to reduce H positive ion. When the reaction takes place, its mechanism is like this: H positive and OH negative. This part should combine with this element, and this must be reduced in the form of hydrogen gas. But non-metals do not donate any electron. It was reaction with water. Third reaction is reaction with dilute acids. In the same way, non-metals do not react with dilute acids. What is the reason behind it? For example, this is a non-metal. When it reacts with dilute acid, H2SO4 or HCl, when any element reacts with acids, in acids there is covalent bond. The bond at first breaks down. For instance, HCl, between H and Cl, 2 electrons are present. That is, the bond is formed by the mutual sharing of 2 electrons. One is contributed by hydrogen, other is contributed by chlorine. But when the bond is broken down, the electron moves towards chlorine atom, because chlorine is more electronegative in nature than that of hydrogen atom. So a positive charge comes on hydrogen and on chlorine, and negative charge is formed. So in order to react any element with acids, the bond should break in this way, and hydrogen is reduced in the form of hydrogen gas. And it is reduced when this element supplies a pair of electron to the hydrogen atom. But here it is a non-metal, and non-metals only gain electron or they share the electron mutually. So here the reaction will not take place, because they will not displace hydrogen atom from acids. This is the second reason. In order to displace hydrogen atom, the non-metal must be highly reactive in nature. These were the two reasons due to which non-metals will not react with dilute acids. Number 4 reaction is reaction with salt solution. It is also a type of displacement reaction, because in this reaction a more reactive non-metal displaces less reactive non-metal from its salt solution. For example, fluorine, chlorine, bromine and iodine. These are the halogen atoms that are present in group 17. they are called as halogen atoms. And as you know that the electronegativity decreases down the group. Electronegativity decreases, it means fluorine is more electronegative than chlorine, chlorine is more electronegative than bromine, and bromine is more electronegative than iodine, or fluorine is highly reactive in this group. So the non-metal must be highly reactive than the non-metal that is present in this salt solution. So you will see chlorine is highly reactive than bromine. So chlorine will easily displace bromine from the salt solution, and it will take its place, and a new salt will be formed, sodium chloride, and bromine will move out in the aqueous solution. Or second example is when we react fluorine with sodium chloride. Fluorine, as we know, it is highly reactive than chlorine. It will take its place, it will displace it, and it will form sodium fluoride, and chlorine will move out. But if we react bromine with NaCl, the reaction will not take place because bromine is less reactive than chlorine, so it will not displace the chlorine from this aqueous solution, hence the reaction will not take place. Fifth reaction is reaction with chlorine. When non-metals react with chlorine, they form covalent chloride. You will remember it in the chemical properties of non-metals. Only covalent compounds are formed. So here covalent chlorides will be formed. They will be present in the form of liquid state or in gaseous state, and these are non-electrolytes. Non-electrolytes means they do not conduct electricity when they are present in an aqueous solution. So here some non-metals that react with chlorine: hydrogen, carbon, and phosphorus, and they form covalent chloride. Hydrogen, when it reacts with chlorine, it forms hydrogen chloride. Carbon, when it reacts with chlorine, it forms carbon tetrachloride. Phosphorus, when it reacts with chlorine, it reacts in two ways. In first reaction, it will form phosphorus trichloride, and in the second reaction, it will form phosphorus pentachloride. Why are two different chlorides formed? Because of the concentration of phosphorus and chlorine. Twice and three times, here twice and 5 times. This is phosphorus trichloride. And this is phosphorus pentachloride. This is carbon tetrachloride. Now the last reaction of non-metal is with hydrogen. It forms covalent hydrides by the mutual sharing of electrons. Here, as you know that hydrogen is also a non-metal, and when it reacts with non-metals, it forms a bond that is called as covalent bond. The reaction takes place by the mutual sharing of electron. For example, sulfur, when it reacts with hydrogen, it forms hydrogen sulfide. Number second is nitrogen. When it reacts with hydrogen, it forms NH3, nitrogen hydride, or its common name, as you know, is ammonia. To balance the reaction, we will multiply ammonia by 2. Here 3 atoms, and nitrogen is present as two atoms, and the reaction will take place in the form of iron. Iron will act as a catalyst. As you know, catalyst speeds the rate of reaction. So it was all about the reaction of non-metals with oxygen.